All right. So, the sum of a number in the series, whatever number we want, is equal to. And what is the sum for an arithmetic series? It's really the average number of the first and last. Now, that's important. You're going to see that terminology on the test. They're going to ask for the average number of the first and last. They want what's in the parentheses. The average number of the first and last multiplied by the number of terms we want to add together. Okay? In a series with a common ratio. Okay? What does that do for us? What does that formula do for us? Correct. In the geometric sequence, right. This will find any term in a geometric sequence. This is an explicit formula. What is D? Common difference. Okay, and that formula is used. Sequence. All right, find any. What type of sequence? Arithmetic sequence. Okay. So we have an arithmetic series, an arithmetic sequence. We have a geometric sequence. So today we talk about a geometric series. Are you using my handwriting right now? Okay. I wouldn't go that far.
I think it's nice.
Do you? It's a lost art, writing in cursive. I can't write in clear.
No, there's a calligraphy pen at the store. Yeah. And you can bust your words and it's so good.
No, not bad.
I think we tried that before.
All right, maybe we'll play with that after we're not recording. Maybe you guys can just show me how to do that. Anyway, here's what a geometric series might look like. All right. First of all, what's important is that you're able to look at a series or a sequence and recognize if it's arithmetic, geometric, or neither. All right. If we recognize this, we're not adding to get to the next number. 6 plus 24 is 30. 30 plus 24 is not 150. So then we want to check out to see that if it's geometric by taking any term and dividing it by the previous term to see if we get the same number. 30 divided by 6 is the same as 150 divided by 30, which is the same as 750 divided by 150. So we do have a common ratio, right? And that ratio is what? 5. So this ratio is 5. Now, what we want to do is we want to find the sum of the first 10 numbers of this series. Could we do it out by hand? I suppose. But sometimes if the numbers get so big, maybe we won't find the sum of the first 50 numbers. That would be impractical to list all the numbers, add them up, put them in the calculator, right? So, to find the sum in a geometric series of n numbers, it's equal to T1, which means what? First term times 1 minus r to the n power divided by 1 minus r. That's the formula. If you want to check out how we get that formula, you can check out the first page of section 11.5. So, I want the sum of the first 10 numbers of that series. I don't need the 10th number. I don't need to find anything else. It's not a two-step problem. The sum of the first 10 numbers is equal to, first term, which is 6, times 1 minus, what is the ratio? What did we say it was? 5. That's our multiplier. 5 to the 10th power divided by 1 minus 5. All right, so then we go to our calculator. I don't know about you. Now, if you want to do this all in one step, it's going to involve a series of parentheses. What I like to do is just go 1 minus 5 raised to the 10th power equals, and then I want to divide it by, if you're going to do 1 minus 5, at this point you're going to have to put in parentheses. If not, divide it by -4, and we should get a positive number. That's a series that is going up. Right? That's what I get in the parentheses, and then I multiply by the first term, which is 6. So I just multiply that by 6. And so the sum of the first 10 numbers of the series is 14,648,436. Okay? So it's a real simple formula to use. It can be tricky if you put it in your calculator, especially if the multiplier is a fraction. It gets a little dicey. But if you take it in steps and do like I did, I think it'll cut down your mistakes a little bit. By the way, we're going to cover one more section, and that'll be on Monday. Did I tell you that? And we're going to test over this on Wednesday. A chapter test, yeah. Well, only up to what we've covered. There's 8 sections. We're only going to cover 6. And then we're going to go to kind of a fun type of topic. We're going to do some probability and statistics. Okay? So we'll be doing some finding out what our chances are of winning the Mega Millions, or even the 3-digit daily number, the 4-digit daily number. What are your chances of winning? And so we want to be educated buyers, or educated gamblers, if you will. Well, that will increase your chances, but is it worth it? All right. So we'll answer some of those questions. All right. So let's take a couple of examples here. Let's say that a student at the beginning of their freshman year, from working odd jobs, 7th and 8th grade, they've managed to save $2,000. Parents open a savings account for them at the credit union, and they have all different kinds of plans at a credit union or a bank. And one plan is a money market. All right? And they're willing to give you 8% interest, which is pretty good, under the following conditions. You have your $2,000, okay? And you're going to put it in at the beginning of your freshman year. Now here's the conditions. First of all, you can't draw any money out. If you do, there's going to be severe penalties. We're willing to give you 8%, but you're going to have to leave your money in there for 10 years. You cannot draw it out. If you do, there's going to be a severe penalty. They're going to take, who knows, right? And then the other condition, it might be as much as 20%. And then another condition is that you have to put in $2,000 at the beginning of every school year, from the time you open. So you're going to put in $2,000 at the beginning of your freshman year, beginning of your sophomore year, junior year, senior year, and at the beginning of every year after for 10 years. Okay? You get the problem? All right. How much are you going to be putting in then for 10 years? How much money? $20,000, right? $2,000 a year for 10 years. How much money do you have? Because after 10 years, you can take the money out. Okay? So, we're willing to give you 8%. So after the first year, you'll have that much money. Okay? After the second year, now at the beginning of the next year, you're going to put in $2,000. So you're going to have 2,000 times 1.08. You're going to put it in September, say. All right. Then next September, you're going to have, I think that's going to be $2,160. Now you're going to have to put in another $2,000 in order to keep this 8%. Okay. But at the end of your sophomore year, you're going to get 1.08. Now take the money that we initially invested here. How long has that money been sitting in the bank for now? 2 years, right? So that's how much interest you've made on the first 2,000. Plus, here's the next one. Now, beginning of your junior year, we're going to put in another 2,000. Well, now the one you put in before your sophomore year, that's been in for how long now?
2 years.
2 years. And how about the one for the? That's been in for 3 years. Okay. Well, this is an example of a geometric series. And we can use our formula. And let's find out how much money we're going to have, the sum after 10 years. It equals the first term. Well, the first term is not 2,000. After the first year, it's going to be $2,160. 2,000 times 1.08. That's term number 1. Times 1 minus the ratio, the multiplier. 1.08 raised to the 10th power divided by 1 minus 1.08. That's our formula. That is a geometric series. Okay. So we go to our calculator. 1 minus 1.08 raised to the 10th power is that number there. It's a negative number. And then divided by 1 minus 1.08. Divided by, okay, I've got to use parentheses here. 1 minus 1.08. I get 14.4865647. And then I multiply that by the first term, which is 2160. Does your answer make sense? Yes. We put in 20,000. After 10 years with all the accumulated interest, we now have $31,290.97. Okay. Now, without your calculators, don't go to your calculator right now. What do you think? How much money do you think we will have if I took the $20,000 at the beginning? Maybe I had 20,000, I put it in the bank for 10 years at 8%. Do you remember that type of problem from the last chapter? How much money do you think we're going to have? Tell me. 42,000. Did you do it in your calculator?
That was a guess.
That was a guess. Why do you say that?
It's about double every 10 years.
How do you know that?
Percent given.
So you think about 8% as a double every 10 years?
Yeah.
Very good, Trey. You were the only one to get it, Trey, out of all 4 of my classes. That's exactly right. I don't know if you recall. Remember I said it was a good investment if your investment could double every 10 years? Okay. Right now it's a little, with the economy, it's a little tricky, but if you can double your, and I think we found out that it was like 7.25%. You will double your investment. If we invested $20,000 at 7.25%, you could double it every 10 years. So at 8%, it's going to be a little bit more. He thought 42. I think it came out to a little bit more than 43,000. 43. If you did any calculators, like $43,100, something like that. Okay. But that's pretty good return, I think. If you can manage to put 2,000, if you can get that 8% interest, I don't know if you can anymore, but on a money market, I know one of the conditions is you have to leave your money there for a certain amount of time. If you can manage to increase that every year, it does pay off. All right, one more example. Let's say we have let's say from 1 to 12, let's say we want to find first 12 terms of -2 times 7 to the j minus 1, not n. Okay. This is asking you for the sum of the first 12 terms. Well, what do I need? My formula, I need first term. My formula is T1 times 1 minus r to the n divided by 1 minus r. So I need the ratio and I need the first term. In order to find the first term, I put 1 in for j. 1 minus 1 is 0. 7 to the 0 power is 1. -2 times 1 is -2. That's my first term times. What do I need to find the ratio? I need the second term, don't I? So the second term, I'm going to put in 2 for j. So -2 times 7 to the 2 minus 1. So -2 times 7 is -14. And what is my ratio? 7. You're going to find that this is going to be your ratio. It's your multiplier. So 1 minus 7 to the 12th power divided by 1 minus 7. Take a look at this problem. Before I do this in the calculator, is my answer going to be a positive number or a negative number? It's going to be negative because inside the parentheses, I'm going to have a negative divided by negative, which is a positive, and then multiplied by -2. So in my calculator now, I'll do 1 minus 7 raised to the 12th power. Uh-oh. I've got a number in scientific notation. Maybe I picked too big of a number. And then divided by 1 minus 7, which is -6. Oh, good. Okay, that's what I get for the parentheses. Don't round anything. And then multiply by -2. And so the sum of the first 12 numbers would be I've got to use commas here. What is that? For what? Billion. 4,613,762,400. 4 billion. All right. Any questions? What we've done? Look at Mr. Shinkonis in the office. You know why he was in the office? Donut Day. Thursday's Donut Day on the south wing here. And I made up a list. Did I tell you about this? Yeah. I made up the Donut Day schedule list. And I include all of the... Oh, this is recording. Okay, that's all right. all the people here on the south wing, all of the male teachers, because the female teachers did not want to be involved, for donut day. Maybe the female teachers would want to bring in fruit, who knows? Or bagels, we don't know. But they didn't want to be involved in donut day, so we took it upon ourselves to assign. Okay, so today was donut day. Anyway, that has nothing to do with math. So your homework is going to be on pages 724, 726, 9 through 54 thirds, and 66 through 73 all.